Hello and welcome to the YouTube channel The Intellect Zone. So this is the fourth video, or rather the fourth chapter of our O-Level Computer Science lecture series. In order to get a better idea about our O-Level Computer Science lecture series, make sure to go and watch the O-Level Computer Science introduction video that we have uploaded in our YouTube channel. So without any more further delays, let's hop into the fourth chapter of this subject. The fourth chapter is named Operating Systems and Computer Architecture. The diagram above presents all the topics that we will be going through in this chapter. Let us now go through the first topic, the operating system. The operating system is a software that works around the background of a computer system. The diagram below points out several features of an operating system. The diagram presents a total of 13 features, but all you have to know is at least 5 of them. But remember, it's always better to by heart them all. Off we go to the next topic, the interrupts and buffers. An interrupt is a signal which is sent by a device or a software to a processor. This signal will cause the processor to stop its current functions and service the device or the software which sent the interrupt. A buffer, simply, is a storage space in the computer system. Now let's talk about the major topic of this chapter, which is the von Neumann model. The diagram below depicts the structure of the von Neumann model. The structure of this model is made up of several components. Let us now go through each and every one of these components. Each and every component in this model are joined together by some links known as buses. Simply, buses are unique links that connect the components of the von Neumann model together. It's the buses that transfer data and control signals within this model. Now let us go through the 3 types of buses. The first type of bus is the address bus. The address bus carries signals relating to addresses between the processor and the memory. It is unidirectional, which means that it transfers signals in one direction. The next bus is the data bus. The data bus sends data between the processor, memory unit, and the input and output devices. It is bidirectional, which means that it transfers data in both directions. The last bus is the control bus. The control bus carries signals relating to the control and coordination of all activities within the computer. It is both uni and bidirectional. Well, this is a general idea about the 3 types of buses. Now let's go through the main components of the von Neumann model. The first component is the memory unit. The memory unit is made up of a number of partitions. Each partition contains an address and some information. The address which is present in each partition will uniquely identify every location in the memory, and the contents will be the binary value stored in each location. The memory unit contains 2 registers, the MAR and the MDR. All this information simply presents a general idea about this component. The next component is the processor. The processor contains the register, ALU. The ALU, or the arithmetic logic unit, performs arithmetic and logical operations. The next component, the control unit, controls the operation of all other components. The control unit reads an instruction from the memory and then interprets it. This component contains 2 registers, the PC and the CIR. We will be talking about these registers in a while. Now let's talk about the input and the output devices. This is the main method of entering data into and getting data out of the computer system. The points below present the function of the input and output devices in the von Neumann model. We will be further talking about these devices in the next chapter. Let us now go through the last topic of this chapter, the fetch-execute cycle. In this process, the processor fetches some data and instructions from memory and stores them in suitable registers. In order to perform this function, the address and data buses are used. Afterwards, each instruction needs to be decoded before finally being executed. The CIR register contains the current instruction being processed. The PC contains the address of the next instruction to be executed. The instruction which is fetched from the memory is stored currently in the PC and then in the CIR. The program counter is incremented by 1 each time when an instruction is fetched from the memory. The fetched instruction is decoded afterwards. After the instruction has been decoded, the processor passes it as a set of controlled signals to the appropriate components within the computer system. Well, this is a general idea about the fetch-execute cycle. All the components in this model perform their function in order to make this cycle efficient. Well, all the topics that we discussed in this video belongs to the 4th chapter. If you need to download the notes for this subject, make sure to check out our official website. The link is there down below. Well, that's basically it for this video. Thanks for watching. And as always, enjoy your presence in this intellectual zone.